All right, let's look at some examples or more practice from section 9.7, which is all about special right triangles. So let's just quickly define these 30, 60, 90, and 45, 45, 90 triangles again. Remember, in a right triangle, whatever angle is the smallest, that means the side that's across from it is the shortest side. So in a 30, 60, 90 triangle, across from the 30 is going to be the shortest side. I always call that W. So 60 is the next biggest angle. That means the side across from that is the next biggest side. That will always be W times the square root of 3. 90 is the biggest angle. The hypotenuse is always across from it, and that's always the biggest side. That's always defined as 2 times W. Okay, so that's going to be the sides for the 30, 60, 90. In a 45, 45, 90 triangle, because the two acute angles are the same, that means that the legs, the two sides across from them, are the same. So these would both be W. The side that's across from the 90 is the hypotenuse, which is always the largest side. And I'm going to take my leg and I'm going to multiply it by the square root of 2. So there's my definition for the sides of a 45, 45, 90 triangle. So let's use those two things to then start looking at some examples. We're going to find the missing sides of the special right triangles. So in my first example, I have essentially a 30, 60, 90 triangle. They're only giving me the 90 and the 60 degrees, but right off the bat, that means that the missing angle is 30. So notice that the side that they've given me is 11, and that's across from the 30 degrees. That's always the side that we want to find because that's representing W. So right off the bat, they gave me the smallest side, which is excellent because then if I want to find the side that represents the length of A, well, because that's across from the 30, if I'm looking at my definition, I need to take my smallest side and I need to multiply it by the square root of 3. So since 11 is the shortest, multiply that by the square root of 3, and we've got our answer for the other leg. So then find the hypotenuse. Remember, the hypotenuse is always going to be double the shortest side. So since 11 is the shortest, multiply that 11 by 2, and 22 is going to be the hypotenuse. If we take a look then at the second example here, in this 30, 60, 90 triangle, once again, the missing angle is going to be 60 because one of the angles is 30 and one is 90. They have to add up to 180. Notice that in this case, the side that's given to us is the side that is across from the 90. So this time, they do not give us the shortest side. We're going to have to set up an equation to find the shortest side. So once again, based off of our definition up at the top, the hypotenuse in a 30, 60, 90 is always 2W. So there's my equation. I get to take 2W and set it equal to 12. So how do I solve for W? I divide both sides by 2. Remember, W is going to be the side across from 30. In this case, that's going to be the side that's represented with the letter D. So take half of 12, that gives me 6. There is my side that is D. Okay, so technically then W is 6. Okay, notice that the other side I want to find is the side C. That's across from the 60 degrees, and across from the 60, you always take the shortest side and you multiply by the square root of 3. Well, since my shortest side is 6, multiply that by the square root of 3, and we'll have our answer. If we take a look at the next example, notice how the triangle is rotated, but we have a 90-degree angle, a 60-degree angle, which means that 30 degrees is the missing angle. So we're still dealing with a 30, 60, 90 triangle. Notice that the number that they gave us this time is 9, and that's across from the 60 degrees. So once again, across from the 60 is not the shortest side. So we are going to have to set up an equation to solve for the shortest side, which we call W. I'm going to take that 9 and set it equal to W root 3. Because once again, that's what represents the side across from the 60. Okay, so I'm going to do my work down here. So we'll have W root 3 equals 9. In order to solve for w, I want to divide both sides by the square root of 3. That gets rid of it and gives you the w by itself. But then here's the thing. This is what we practiced at the very beginning of this chapter. I never want to have a square root in my denominator. So we have to do something called rationalizing. If I have a square root of 3 in the denominator, I need to pair it up. So multiply it by another square root of 3. But if you do that to the bottom of your fraction, you have to do it to the top. So when I multiply straight across, the 9 and the 3 cannot be actually multiplied together because 9 is not under a square root and the 3 is. In the bottom, the whole point is that we ended up with a pair. A pair moves outside of the square root, and then it becomes just 3. I'm not quite finished because I've got several numbers that are outside of the radical, and I can simplify. 9 divided by 3 gives me 3, and there's still the square root of 3 with it. So I know that that looks like a bigger number potentially, but that's my shortest side. E, which is the side across from 30, is the shortest, so E is 3 root 3. To then find the side of F, well, remember, that is going to be across from the 90, which means that now that I know what my value for the shortest side is, which is 3 root 3, we have to double it to get the hypotenuse. So to find that missing side of F, I need to take 2 and I need to multiply it by 3 root 3. Now remember, when you multiply, because the 2 is not underneath the square root, it gets multiplied by the number that is not underneath the square root. So the 2 and the 3 on the outside get multiplied together, which is 6, and then the square root of 3 would stay as it is. So there are my 2 answers for that triangle. Let's keep going. If I take a look at the next one, notice that we have another 30, 60, 90 triangle. Okay, the angle that's missing is the 60. Notice that the side that they've given us, though, is the side that's across from the 30. So they have given us the shortest side, which is perfect. If they've given us the shortest side, there's no need to do a whole bunch of algebra. We're just having to do some multiplication instead of solving an equation. So remember, G is across from the 60, which means that I want to take that 2 root 3 and I want to multiply it by the square root of 3. So when I have several radicals being multiplied together, remember, I'm going to multiply those, and it's normally under a square root. But because that's a pair, I know that it's going to end up then moving outside of the square root. So then 2 times 3 is going to give us then the second side, the second leg, which would be a length of 6. My H value is the hypotenuse in this problem. Remember, 2 root 3 is the shortest side. My hypotenuse, I always take my shortest side and I double it. So I take that 2 and I multiply it by 2 root 3. So that means that the numbers that are outside of the square root get multiplied together. 2 times 2 is going to give me 4, and I keep the square root of 3 as it is. And those are my 2 missing sides. All right, if we continue with the next one, notice that I'm giving you a 90 degree, a 60 degrees, which means my missing angle is a 30. So we have another 30, 60, 90. Notice that the side that they gave us is the hypotenuse, which is definitely not the shortest side. So remember, I'm going to take what the hypotenuse is. I'm going to set it equal to what it represents, which is 2w. And now I have an equation where I can solve for w. So all I have to do is divide both sides by 2, and that's going to get me the shortest side. Notice that it's the numbers that are on the outside of the radical that I need to divide. So 6 divided by 2 is going to give me 3, and I keep the square root of 3. Now remember, that's the shortest side. Which is the shortest side in this triangle? Well, it's always the side that's across from the 30 degrees. So that means K is a length of 3 root 3. So J is going to be us taking 3 root 3. And remember, I want to then multiply that by the square root of 3 because it's always W root 3 across from the 60 degrees. So that's how I calculate to find the side for J. So once again, the numbers that are underneath the radical are what we multiply together, but because they're the same number, it's going to turn into the product of 3 times 3. So the missing side is a length of 9. All right, moving on to the next example. Notice that the only angle measure that's given to us is a 90-degree angle. So how is that going to help me? Well, I notice that I have two sides that are marked congruent. If two sides are marked congruent, that means that they have two angles that are congruent. And so in order to have three angles add up to 180, these two angles are going to have to be 45 and 45. So, luckily, we could have not even known the 45-degree angles. And because I have angle M, or not angle, but side M, marked the same as that side that is given to us as 13, I know that M is also a length of 13. It's just a matter of I needed to know that it was a 45, 45, 90 triangle now in order to find what the hypotenuse is. Remember our rule. If I go back to the top, our definition is that the two legs are congruent. They're both W, but in a 45, 45, 90 triangle, I multiply that by the square root of 2 to get the hypotenuse. So 13 is the, where am I at? 13 is going to be the leg, and then I multiply that by the square root of 2, and that becomes my answer for the hypotenuse. Okay, if I take a look at the next example, we have a 45-degree angle, which means the other one also has to be 45. Notice that the side that I've given us is across from the 90 degrees, so that means 3 root 2 is the biggest side. So remember, that means we have to set up an equation to solve for the small side. Because it's going to equal W root 2, I'll set those equal. Hopefully you notice that if I was to divide both sides by the square root of 2, those are going to cancel out, and it's going to leave you just with the number that is in front, which is the number 3. And because the two legs are congruent in a 45, 45, 90, they're both a length of 3. Same idea with this next one. I'm giving you the side that is across from the 90 in a 45, 45, 90 triangle. So once again, I have to set that hypotenuse equal to W root 2. So I got to get the W by itself by dividing both sides by the square root of 2. This is where maybe a little bit more algebra is going to come into play because I'm dividing by a square root of 2. I never want a square root for my answer, so this is where we have to do some rationalizing. I'm going to multiply both the top and the bottom by the square root of 2. When I multiply straight across, I get 20 root 2 on the top. Square root of 2 times the square root of 2 will be 2. And then notice that we have some numbers that are outside of that radical. So I get to divide those, and I get 10 with the square root of 2. Now, because that is representing W, which is the shortest side, and that happens to be both of the legs, that means that both R and S equal 10 root 2. If I take a look at the next one, we are dealing with another 45, 45, 90 triangle. I'm giving you one of the legs, but remember, legs are always congruent. So that means right off the bat, without doing any algebra, I know that the side of U is also 6 root 2. But then remember, that's the shortest side. To find the hypotenuse, which we're calling V in this problem, I have to take my leg and I have to multiply by the square root of 2. So once again, because I have two numbers that are underneath the square root and they're the same number, it's going to end up moving outside of the radical, and this ends up being a 6 times 2 problem. Well, 6 times 2 is 12. So 12 is going to be the length of the hypotenuse. And then finally, our last problem here. We have another 45, 45, 90 triangle. The side that is given to us is across from the right angle, which means that we do not have the shortest side. We need to set up an equation to find the shortest side. It's always W root 2, which is the hypotenuse in a 45, 45, 90 triangle. So that means that we have to divide both sides by the square root of 2. So I'm going to do it down here. To get the W by itself, we'll have 13 over the square root of 2. Just like some of our previous problems, we're going to have to rationalize. I multiply both the top and the bottom by the square root of 2. Multiplying straight across, we'll have 13 root 2, and that's going to be over, because we have the same number underneath the square root, it moves to the outside, and you're just left with a 2. Now notice that in this particular problem, the numbers that are on the outside, which are 13 and 2, they don't simplify down nicely any further. Because we're trying to find the legs and the legs are congruent, then I know, because the 13 and 2 are not divisible, it doesn't look like the prettiest number, but that whole fraction is my final answer. So 13 root 2 over 2. So once again, you just want to make sure you're very, very familiar with these two definitions of these special right triangles. And if you are given the shortest side right away, it's just a matter of multiplying pieces to get the other missing sides. But if you are not given the shortest side, you have to set up an equation to get the shortest side before you can then finish the problem.